All right, folks, let's take a look at the guided practice for week 11.1. This is section 11.2 from your text, the section on quadratic formula. So let's dive right in here. It says, for the quadratic formula, we will now use the general method of completing the square to find the solution to every possible quadratic equation. What? We're going to solve ax squared plus bx plus c equals 0. Without knowing what a, b, and c are, we're going to find a general formula for what the answer is. So what does this mean? If we can do this, any quadratic in this standard form can be solved. I should say any quadratic equation. Any quadratic equation in this standard form can be solved using the following resulting formula. So let's find it. So what we're going to do is we're going to complete the square. And if you guys remember how to do that, this is a quadratic whose lead coefficient is not necessarily 1. So the first thing that we're going to do here is we're going to subtract c from both sides. And that's going to give us ax squared plus bx is equal to negative c. And then the next thing that we're going to do is we're going to divide every single term by the lead coefficient a, so that we do have a leading coefficient of 1 for our square. So this is x squared plus b over ax is equal to negative c over a. Moving back down to the next row here. We are now going to start completing the square. So we've been doing this a lot lately, and hopefully you're with the following maneuver. But I need to add the magic number to both sides that's going to make this a perfect square. Now, in order to do that, typically what we do is we take this middle term, we multiply it or cut it in half, multiply it by half or divide by 2, and that's going to give us b over 2a. Then we take that value, b over 2a, and we square it, and we add it to both sides. So, let's see, that's going to be b squared over 4a squared, if I multiply that out, plus b squared over 4a squared. And now what that's supposed to have done is, that's supposed to have completed the square. That is to say, the left side will factor as a perfect square. The right side, we're going to have to clean up the algebra a little bit. So we have negative c over a plus b squared over 4a squared. And what I'm going to do on the right side there is get a common denominator. So we're going to need a 4a top and bottom so that they both have the same denominator. On the left side, remember that that perfect square is always going to factor as x plus whatever half of that linear term was. So this, or coefficient. So this is b over 2a. There it is. So what do we have? Well, we have a mess. Let's clean this up. This is x plus b over 2a squared is equal to negative 4ac plus b squared all over the common denominator of 4a squared. And now that this left side is a perfect square, we can now use the square root property, which says that this left side, x, well, I don't need the parentheses anymore, I guess. I'm going to take the square root of both sides, and I get x plus b over 2a is equal to plus or minus the square root of, I'm going to write this as follows, b squared minus 4ac all over 4a squared. And the next thing I'm actually going to do here is, like we've been doing in the past, I'm going to write that as two radicals. The radical of the numerator, square root b squared minus 4ac, divided by the square root of the denominator, which is the square root of 4a squared, which is really just 2a. And so we're on the home stretch now. Solving for x, I'm going to subtract b over 2a from both sides, although I don't necessarily have like terms here. And what I get is x is equal to negative b over 2a plus or minus the square root of b squared minus 4ac over 2a. And since they have a common denominator, I'm going to do one last thing. I am going to rewrite this in the following manner. This is x is equal to negative b plus or minus the square root of b squared minus 4ac all over 2a. And that, folks, is what we call the quadratic formula. So that will tell you what the answers to this equation are if you tell it what a, b, and c are. So all you got to do is plug those numbers in. This is called the quadratic formula. Bang. Nice. Now let's learn how to use it. So anytime you have a quadratic equation, you're going to want to do the following. The first thing that you're going to want to do here is write this equation, x times 2x plus 3 equals 1 in standard form. So the first thing that we're going to do is we're going to multiply that out. That's 2x squared plus 3x is equal to 1. And then we're going to bring everything over to one side, so that this is preferably with our leading coefficient 2 being positive. 2x squared plus 3x minus 1 equals 0. Now at this point we should know lots of different ways to solve that. You should maybe be able to factor it if it factors, but we're not always guaranteed that it'll factor. And you can complete the square, but we just completed the square up above on every single equation ever, generically, and this is the answer that we got. So all we have to do is identify a, b, and c. In this case, a is equal to 2, b is equal to 3, and c is equal to, whoops, careful here, you got to include the sign, c equals negative 1. So let's see, let's color code this, man. There it is. And once we identify that, we can substitute that information into the formula, which says that x is equal to negative the b value, which is 3, plus or minus the square root of the b value squared minus 4 times the a value, which is 2, times the c value, which is negative 1, all divided by 2 times the a value, which is 2. So those are my answers, and now all we have to do is simplify it. So x is equal to negative 3 plus or minus the square root of 9. This is a negative times a negative, so that's going to be positive. 9 plus 8, yikes, all over 4, and we get negative 3 plus or minus the square root of 17 over 4. And those are our answers. There are two of them. Either x equals negative 3 plus the square root of 17 all over 4. And again, I want to stress that that's all over 4, not just the radical. The entire negative 3 plus 17. Yeah, come on. Is over 4. And the other answer is negative 3 minus the square root of 17 over 4. So those are our two answers. Now, those numbers aren't nice numbers, I guess you could say. And so what that means is Probably back here when we were trying to solve this equation, probably trying to factor it wasn't going to work out. In fact, we can try that. Let's see. Factor? Well, how would it factor? Well, the leading coefficient is 2, so I would need a 2x and an x. And then the last number is 1 and 1. So, well, the last number is negative 1. So one of these is going to be positive and one of these is going to be negative. But this is positive and this is negative. Then when I multiply the outers, I get negative 2x plus the inners. That's a negative 1x, which isn't 3x. So my other option would be to have the first one be negative and the second one be positive. But then I have my outers as being 2x minus the inners, which is x, which is positive 1x, which is also not 3x. And so this is going to fail either way. Factoring is not going to work out too great there. And plus, you know, when you ask yourself the question, can you think of two numbers that multiply together to give you negative 1 but add together to give you 3? No one's going to say, oh, these are the two numbers that does that. You're not going to come up with those probably off the top of your head. So that's why this quadratic formula is so nice. So let's try another one.